Hi everyone, I'd like to welcome you to our session from comtac. We will like you today to bring you to the LoRaWAN design process. We from comtac, we are a design house for custom-specific electronics. We have a background of 32 years experience in designing custom-specific electronics. First of all, the question is, why should you design an own hardware? What are the advantages? And why not to choose a design or a product which is already on the market? The key for that question, to answer that, we see is in the full cost of ownership. You should always take into account what the costs are through the full life cycle of the product in the field. A lot of costs is not only the device costs, but are costs which you have for the installation process, the configuring of the device itself, in the installation process. Maybe if you have a bad antenna performance, you must install additional gateways which are very expensive, and therefore we have on a lot of our devices the possibility to connect an external antenna to it, so that you have a better antenna performance even if you install your device deep indoor somewhere in a traverse station or in a building or whatever you have. And beside of that, if you have your own device, you are master of that, and you have always the guarantee that you can produce it, that you have no unexpected changes in it. You have always the same firmware, you know exactly how the device works, and you have no, you are absolutely sure that you always can guarantee a replacement in the field for your customers. For that, an important thing for us is we have a wide range of existing devices. So we have a really big experience, and we are really fast in adopting that from other devices into a new device. So it means we don't have to start from scratch, and we have always a good basic for that, that you can go fast inside the product development. Today, we'd like you to show you the design process on a new product. We already launched that. We call it the short circuit monitor. It's a pretty cool device. We didn't see that on the market up to now because it has 8 universal IOs. That means you can configure each IO as an input or as an output as you need it on the field in the device. And that's pretty cool because you can configure it by LoRaWAN download message, and you can really have that device exact fitting to your application in the field. We call it a short circuit monitor because one application is to monitor traverse stations which have a short circuit switch in it, and they have typical outputs that you can reset the switch remotely, and for that you have the possibility to change. For example, you can use 6 as input, 2 as output to reset the switches in the field. And that's pretty cool. And even the antenna, we have an inside antenna with a SMA connector, and there you can connect an external antenna if you don't have coverage in the field. Yes, so let me take you to the design process for LoRaWAN device. How does that work? First of all, we have your idea, your application, what for problem do you have, and which do you solve with a device in the field. After that, you make a concept how you can solve the problem in the field with a device, with a network, and with a cloud service, of course. Later on, you go into the definition, you make a detailed specification of the device itself. We have really big experience even with norms, regulations, especially in the ISM frequency band. We have different regions worldwide, and you have to take that into account even if you design the payload, for example, in a LoRaWAN device. Then we really start with the development of it. We make schematic, layout, we build a prototype, write firmware and test it really, and we go to certification with the device. If that's already done, we have to think about the industrialization. because you like, of course, to have a big amount of devices in the field, and you need a test adapter and all the things you need for the production. And that, because of our sister companies we have in the same company group, it's pretty interesting to work with us, because we can provide you the full service, even from the development to the production of the device itself. And of course, at the end, you have your product, your lifetime, and you have your product inside the market established.
I will show you now more detail how we developed the product, one of our products. Before we start with the development of this new product, we need to fetch and process as much information as we can from the customer for the product. Like that, we can start with the design concept. The design concept builds the backbone of the hardware and firmware development, as all functions needed are mapped to specific components and that are needed to run these specific functions that we want the device to do. The more details we know about the product, the more advantages we will get on the cost of ownership, as we will be able to optimize the product to fit these preconditions perfectly. Once the concept is defined, it is important to keep in mind we're developing a product. So to be successful, we need to see it as a system and plan it as such. Otherwise, we might forget important stuff in a really later stage of the project, which will be actually not that good. During the hardware and firmware design, it is not only important to keep in mind the norms on which we're developing the device, but also to keep in mind testing and production at all times, because at the end of the day, this is really important for the product once we're ramping up. It is also important to have a clear idea on how to handle the device on the field, or let's say in another way, how the device will be handled on the field, because if we know this, we can use this information to design the device to fit these conditions, so we really can use this as an advantage. Because of what Stefan said before, it is exactly these points that are really important and help us reduce the cost of ownership of a product. So these are really important things when developing a device. So now to a really critical thing when developing battery-powered IoT devices, which is actually the battery choice and the battery management around it. By optimizing these 2 points, we can get the maximum lifetime from the device, which at the end will reduce the efforts, to replace batteries on the field, which at the end also will reduce the cost of ownership. We recommend you guys to calculate and build a device consumption profile as precise as possible. Take as many variables into account, like battery self-discharge, temperature profile, and so on. It is important to know that not all batteries are suitable for all products, so it is important to look at that. Take care about not only looking at the datasheet, but also making measurements with the battery, discharging them, or for example, try to simulate them. The actual energy we can take out of the battery is at the end much smaller than the nominal energy we see on the datasheet. So this is really a critical point for us to know how long our system is actually going to work on that battery. Take special care when choosing the DC-DC converter, as it is not always important to have the highest efficiency, but in our case, for example, as we're battery powered, we need to actually have the lowest quiescent current, as we're always sleeping. Last but not least, do not forget to take care of the battery management concept from the beginning. The way you handle the current process of your device will have an impact on the energy you can take out of the battery, so it is important to take a look at this. As you can probably see, the optimal performance for our device is only reached when we have optimal hardware and optimal firmware playing together. Another key point of a LoRaWAN sensor, in particular of our sensor, is the antenna which is included on it. To boost the antenna performance of our device or of your device, it is important to keep the antenna in mind during the whole design process. Don't just leave the antenna aside and place it at the end. Integrate it from the beginning and build your device around it. Take care of the correct grounding, try to avoid having supply tracks close to it, and also try to separate components, like big components, away from it as much as you can. Also, do not forget to integrate a PI filter, as this is gonna help you tune your antenna into real life situations. Every component on your board, the housing, all of this will detune your antenna, so it is really important to take care of all these factors whenever you're designing. To tune our antennas here at comtac, we usually use VNAs. Real accessible VNAs will already do the job of showing you in which direction your tuning is going. But obviously, the most you invest, the most information you can get from your measurement device and from your device itself. By taking all these recommendations into account, you can see that we developed a device with a specific housing, and you can see the PCB form turned around specifically so that it fits on the housing. So we used space as much as we can. We added the groundings on the antenna, and we have a specific boost selected for our device, so we have the best energy consumption we can have. All of these elements build at the end a perfect product that fits these perfect conditions and allows us to reduce the cost of ownership massively.
Thank you, Anders Ramirez, for your explanation of the LoRaWAN design process. You are really a LoRaWAN expert, and we are really happy to have you here at comtac in our company. Please, if you have any questions, don't hesitate to contact us, and we would like to thank you for your attention here. Thank you very much.
Have a nice one. Thank you all.